just be take home, take it whenever time you want. I'll schedule an office hour, maybe from like 6:30 to 7:30 that night, in case you want to schedule when you take it then. That's just about the time that I usually have given it in the past. And so if you want to take it then, and then I'll just be on Zoom if you want to ask, clarification questions then.
Are we supposed to slot out like a specific like 2 or 3 hour window when we're working on it, or is it like an all day thing?
2 hour, yeah. So
Sure.
it's timed, yeah, because I want to try and simulate, the prelim for you as best as possible. So it'll be timed to 2 hours. So you have to find your 2 hour time slot to take it. Cool. Anything else? Okay, I see that AJ is on. AJ, you had a couple questions you just wanted me to talk through. I don't think they'll take too long, and then we can maybe do a practice problem. Did you just want to repeat them? Because I know we talked through some of them the other day.
Yeah, just one or two of them.
Okay. Sorry, just any of the things that you asked me, I could talk about.
Yeah, whatever you deem appropriate.
Okay. All right. So since it's most recent, let me go back to the question you had about what we did yesterday. It looks like you just wanted me to recap this calculation of the odd solution. So if you remember yesterday, we had the heat equation defined on the quarter plane, and with the Dirichlet, what's called the Dirichlet boundary. So it just means the boundary condition is with respect to the value of the unknown function. And then we have some initial condition here, okay? And essentially what we said is that you can solve this by odd extension, okay? And if it were a Neumann boundary condition, or one that depended on the spatial gradient, you would solve it using even extension. What does odd extension mean? It just means we're going to define g tilde x is equal to the signum function, sometimes it's called, times g of the absolute value of x, okay? So this just means if I have like my g was equal to something like this, then my g tilde would be the extension that you get by odd reflecting it, okay? And the reason this works is that it doesn't matter how the solution is defined over here. What only matters is that you have consistency here, and in particular that this crossing through zero is satisfied. And for continuous odd functions, you have to cross through zero. So maybe that's a good mnemonic for remembering that. Okay, but I think the specific question you had, AJ, was just when we're computing what the final solution looks like, u of xt, right? The u of xt, right, is given by now my fundamental solution times g tilde of y dy, okay? And by requirement, in oddness, you can show that this satisfies our boundary condition. If I go ahead and plug in my definition here that I've used for g tilde, what I get is this integral from 0 to infinity of just my function that I started with, plus the integral from minus infinity up to 0 of phi of x minus yt. And now I have a minus g of minus y now, right? Because, absolute value of y when y is negative is minus y. So, so you were just asking basically how do you get from here to the next step? Well, if I if in this integral, right, I just take z is equal to minus y, then dz is equal to minus dy. And this thing now is going to be equal to what? Well, I'm going to pull that this minus sign out front here, okay? I have to convert, right? If I plug in 0 for 0, so y equals 0, right? Z equals 0, and at y goes to negative infinity, I have z goes to infinity. So I end up with an integral from infinity up to 0. And then, z equals minus y means that I'm going to have a phi of x plus z t here. And then I have my g of minus y, but that's just going to be g of z dz. Okay? So that was the step in between. And now if I switch back to just calling z y again, right? And I reverse the direction of integration with this by taking its negative, right? Then I'm going to get, let's sort of sneak this down here. U is equal to, well, the integral from 0 to infinity of phi of x minus y t g of y dy. That's just my first integral that I've left alone, okay? And then I get a, confuse something here. Okay, sorry, this should be a plus here, right? Because of my dz term here, that's the one thing I missed, right? So I pulled the minus out, but then this dy becomes a minus dz, so this should be a plus.
Professor, why do we get a negative argument in the second term, g of minus y or minus g of minus y? Why do we get a minus y there? Shouldn't it be plus y as well?
No, because g is not defined for values of its argument that are negative. So that
Oh.
means that when y is negative, I need to take the negative value of y. So then,
Okay.
negative times negative gives me a positive, right?
Yeah.
Yeah. Okay. So yeah. So sorry, I screwed this up, but this minus dy here, right? Or this dy here becomes a minus dz. So then you get a plus sign up front. So then when you flip the direction of this integral, okay, now you get